Now let us begin with our webinar for today. We're talking about using AI or LLMs to analyze and monitor wireless, and I'm going to get really picky about that AI LLM stuff here in just a few minutes. But we're going to talk a little bit about how they work and help you understand that so you could therefore understand how they might be practical useful. Then we'll take a look at some examples of using it, and we'll even explore a solution among several that are out there that can be used to do more complex processes and automate some monitoring and things like that in our environment, regardless of whether our vendor actually provides an AI-based solution in relation to their Wi-Fi networks technologies or other technologies at all. All right, so to start, I want to say this. It ain't nothing new. So, there's been a lot of craze the last 4 years, particularly 4 and 5 years, about LLMs, and everybody wants to talk about AI when they mean LLM, which is a form of AI, but they use phrases like, how is AI going to change our work processes? How is AI going to impact network administration? How is AI going to impact programmers? Well, the reality is that AI has been changing work practices for decades. AI has been impacting programmers for decades. AI has been impacting network operations for decades. It's just a lot of people don't understand what AI has given to us because they haven't followed the history of it. So when I say it ain't nothing new, let me be clear. It ain't nothing completely new, okay? There is definitely new stuff that has come along to us in the last 8 or so years since a seminal paper was published by Google Research called Attention is All You Need. But regardless of that, AI has been impacting our environments for a very long time. The reason AI is getting the attention today is, one, because the LLM subset of AI, or generative AI, has gotten a lot of attention because it's the first time that general human beings can interact with a responsive AI solution of any kind and see some kind of result that makes them feel like they're interacting with an intelligent entity. And so therefore, there's this idea that AI has done something it's never done before. But we've really been doing generative AI since the 70s. You can go do your own research, look at the research papers. You'll see that generative AI was being done in the 70s. Was it as good as today? Of course not. But OCR wasn't as good in 1995 as it is today either. So everything AI gives us improves over time. The second reason it's getting so much attention is, hey, when you spend billions of dollars on something, hundreds of billions of dollars, it gets attention. It's that simple. So we've got a bit of a bubble going, and we'll have to see how much bigger that bubble can expand before it decides that it's going to hopefully slowly contract or explode. So it's not completely new. The point is, if you want to understand the modern LLMs, the best thing you can do is read a good overview of the history of AI, and that will give you a lot of understanding on it. But I'll give you some insights throughout this presentation as well. There are some core principles that I want you to keep in mind. First of all, AI does not equal LLM, but LLM does equal AI. Okay, so this is the first thing. I get really frustrated by people saying, how can we implement AI, or how are you using AI in your business? And literally the only thing they're intending to be talking about is this one subset of AI called large language models, or maybe generative AI of something other than a large language model, but they're dealing with mostly LLMs. So AI does not equal LLM. AI is far more expansive than that and more capabilities than that. LLMs are, however, very much so memory and processor intensive. These things are energy consuming beasts. For example, if you want to run a local large language model using the open source tools like Olama and other interfaces and solutions that abstract really the complexity of doing it, but they give you these interfaces so that you can run various open source models. on your local machine, you will find that, yes, you can do it, but it's either going to be extremely slow or you're going to have a real workhorse to get it done, meaning that you've got either a single very powerful graphics processing unit or multiple graphics processing units that give you aggregated power. And by power, I mean both GPU processing power and RAM. And so they're very processor and memory intensive. So that's just using them, the training of them even more so. In fact, to run something like ChatGPT, Gemini, Claude, Perplexity, etc., you're talking about power consumption for those systems of a medium-sized city. In other words, the same power that would be consumed for that whole city being consumed just to run one of these large-scale LLMs. Now, granted, they're servicing hundreds of thousands or maybe millions of requests per day, but the point is that they're power hungry. They can therefore become quite costly from two perspectives. One, if you want to implement it locally, and we're going to talk some about that. And two, even if you use APIs. So a good strategy, we're starting to get to that phase of realism with the, quote, AI bubble. What I mean by that is back in the 90s, there was this launch of the internet bubble, right? So everything was about how do you use the internet in your daily work? How can your business benefit from the internet? What jobs are going to be taken away because of the internet? All these same exact things. We heard it in the late 1990s into the early 2000s. And by the way, if you go back further, late 70s, early 80s, what we heard about completely was, oh, what are you doing with computers to optimize your business processes? How are you getting more done with computers? Oh, and what jobs are going to be lost because of computers? There was this move of this concept of office automation was the phrase that was used a lot. So the point is, because of computing technology, it seems, every couple of decades, we've had another big thing come along, and everybody was saying, oh, the world's going to be horrible in the future because of this. And you can point out reasons why AI could potentially be different. Certainly you can. But what we have learned from the past is, generally speaking, these advances in technology go through a sequence where it starts with overhyping, and we think they're the best thing ever. And then you start to get into the phase where you start to get the little hints of, ooh, maybe it's not quite what we thought it was. And then you start to move into that strategy phase where you get real world understanding of how these things can benefit you. So one of the things we're seeing now is stop thinking you're going to have LLMs do everything for you, and instead use them where they're best and use other tools in conjunction to remove the LLM workload. Now, what do I mean by that? Well, let me just give you a very simple example. If you have log files and you want an LLM to analyze those log files, well, did you know that there are things in log files that are definitely not problematic? They're just information type entries. You could clean up your log file first before submitting it to the LLM. And let's say you're using APIs with something like ChatGPT or Gemini or Claude or whatever. Then the reality is what you're charged for is usually a couple of things. The number of operations or requests that are made and the size of the operation or request, meaning how many tokens are consumed. I'll explain what a token is more later, but how many tokens are consumed both by your request and the response. And so if you can reduce the number of tokens that you need to provide in the request to get the results you want, you reduce your cost. And this is a big mistake a lot of people make when they're using AIs. And there's two negatives of this. One, you pay more. And two, you're costing the whole world more because you're consuming unnecessary energy, meaning that your CPU, for a lot lower cost, could quickly clean up the data before submitting it. And the cost of that cleanup is less than unnecessarily having it go through an entire attention-based neural network to clean it up before it can process it. So think about strategy. How are you using it? What old school techniques we've been using forever can be done before the new school techniques so that the new school techniques get you what you need from it. Now, how are we using AI in network operations? Well, we use machine learning, not LLMs here, machine learning. which is things like supervised learning and unsupervised learning. So supervised learning means that it's labeled training data. Generally speaking, we have an example of input that would be provided to the machine learning system and what valid output should be based on that input. So that's supervised, and that's what we call labeled data. So the input might be an error message, and the output might be a recommendation for how to troubleshoot that error message, right? So that's an example. And so you might have one error message with 5 different valid outputs of different ways to troubleshoot it, and then another error message with 11, and another error message with 2, and so forth. That would be an example of labeled training data of supervised learning. Unsupervised learning is unlabeled training data. Basically, we're expecting the machine learning algorithm to look at the input and look at results that are occurring, and over time, understand, okay, when I get this input and the context I exist in is X, then this is the result. When I get that same input and the context I'm in is Y, meaning the state I'm in, what are the different configurations and activities and things going on around me, right? Then the result is this other thing. So that would be unsupervised learning. And then you also have the concept of reinforcement learning, or RL, which is going to be based on rewards. So the AI, the machine learning system, gets rewards based on its outputs. There might be environment-based rewards, meaning that functionality is improved when the AI makes a certain decision. There's sensor-based rewards, where it's actually reading data from sensors. So the AI learns, okay, when I change this setting in the thermostat, I get this new temperature 10 minutes later. And so it's understanding from that how to adjust the thermostat to accomplish an end goal. Multi-agent rewards is getting inputs from multiple different agents, and then human response rewards. This is reinforcement learning with human input. And what it means then is a human looks at the output and says, yay or nay, I like it, I don't like it, true or false, you're right or you're wrong. And over time, the machine learning system learns from that. And then we have predictive AI, which is basically like taking machine learning and then adding statistical analysis to it. And so we can therefore predict the future based on the current and the past. And then finally, you have what everybody seems to be crazy about today, and they keep, much to my frustration, just calling AI, and that is generative AI, the most common being large language models. So what are vendors doing in the networking space with AI? Well, let me just give you a sampling of a few vendors. So Cisco, for example, has their deep network model, which is an LLM trained on historic Cisco expertise. So their training materials, discussion forums, CCIE blogs, all that kind of stuff. So they've got all their old data, they train on it, and then they have this beta Cisco AI assistant. I don't know if it's gone final or even if they may have canceled it, but this is a project they've worked on, right? So they're trying to take advantage of LLMs here. And then machine learning for network analytics. They have agentic ops as well. And then you have Juniper Mist in the Wi-Fi space, pretty well known for their AI stuff. So they've got Marvis, which includes machine learning analytics, an AI assistant, and other things as well. And that's Marvis, not Marcus. Apologies to Juniper Mist. And then Extreme Networks has some things too. So they've got Extreme AI for smart omni-edge machine learning, and their AI Expert, which is an LLM based on, I think they say something like 30,000 support documents and technical documents and troubleshooting procedures and best practices, things like that. So these are just a few examples. But let me clearly say something. We've all heard in the Wi-Fi space of ARM and RRM and whatever other M they want to talk about. It's been out there for 15 plus years, something like that. Maybe, I don't know, probably goes back to the 2000, before 2010, some of the earliest implementations. But the point is, even if it wasn't called that, there were various automatic self-configuring behaviors provided by Wi-Fi vendors and network vendors in general. And I'm going to make a bold statement. those were effectively in the category of AI. Artificial intelligence is nothing more than automatic decisions based on computational algorithms when it comes to network self-configuration. So even if you're just dealing with a hierarchy tree for decision processes, a branching tree, then the reality is that is categorized as a form of AI. And yes, it's an early form, an early example of it, but it's still AI. So, we've got our, when we all shop online, you go to your favorite online place to shop, which mine happens to be American Musical Supply over the last few years. Not that I bought a lot of things there, but I like looking at a lot of things there. You can always dream about getting a $5,000 acoustic guitar, right? And so the point is that with these tools, they have functions that they call recommender systems that have been used in online stores since the late 90s, early 2000s. And basically, it looks at its data and says, well, we had 1,000 people buy this product, and 180 of them also bought this one. 90 of them also bought this one, and 20 of them also bought this one. And those are the three highest also boughts. So we're going to take those three things and add them in. It's making an intelligent decision about what else to recommend. Hence, it's in that subset of AI. And the AI back in the 80s and early 90s that was the big talking point was what were called expert systems. And expert systems were basically decision trees in most cases. It's funny, you can actually watch 1980s, 84, 85 range episodes of the Computer Chronicles on YouTube. If you've never looked at any of those, go check out the Computer Chronicles. It's the entire archive of every episode of the Computer Chronicles from I believe it was 1983 to 2003, something like that. Basically the major window of the personal computer revolution. And they talk about AI in there. And it's funny because Gary Kildall, who passed away in the early 90s, but was in those early episodes, and he was a huge influencer in the early computer space with operating systems and so forth. He actually would question these people and say, okay, so you're not really doing anything other than, and then he would describe it, and you'd see their faces get a little bit red because they were trying to say something was AI that maybe didn't even qualify. But what most people were calling expert systems or AI was just an intelligent decision tree. And after all, that's what it means, right? Artificial intelligence. So maybe it's not great artificial intelligence, but it's artificial intelligence at some level. Certainly not AGI or general artificial intelligence or artificial general intelligence. All right, let's talk a little bit about how these LLMs work. First of all, we need to think about how they treat data. So let's take just this word house. And the way an LLM might treat this word house is it's going to look at it in a vector space. Now, I'm simplifying this, but I want to help you understand the concept. So within this vector space, we might have some various ranges. So you can think of house as storage, right? I'm going to house my car somewhere. It's a verb now, and it's about storage. Or I could be referring to a home. Or it could be referring to a building or a box. In other words, a container, the place in which you house it, right? So these can all be varied meanings of this term house. And we don't always think of it every day in our language when we're using terms. But we never use a term, well, I shouldn't say we never use a term without other terms in context, but we never use a term without context. For example, if I look at my dog and say sit, there's just one term there, but it's in a context. There's a tone of voice. There might be a physical motion associated with it. The dog interprets that in a vector space and understands what I want it to do, unless it happens to be a Great Pyrenees like mine, in which they generally ignore every command you give them and do whatever they want. I actually have a t-shirt about Great Pyrenees following commands, and it gives all of these commands and the Great Pyrenees just stays in the exact same position no matter what you do. And then in the final command, you say stay, and then that box on the t-shirt is empty to indicate the dog has left, because that's how they seem to act. But the point is that we can represent this concept that we have of human language, that context applies different meanings to terms, even though it's the same, in this case, 5 letters. So, for example, we might take house and say on the storage to home spectrum, well, it's over here at about a 9. And on the box to building spectrum, it's up here at about a 9. And this is going to give us a vector of 9, 9. And then we might also say, well, but there's another representative of a vector of maybe -9, -7, right? It's still the word house. As humans, we look at context and we take that word and we pour meaning into it for context. Computers need to have some method to do the same thing. Now, again, I've oversimplified it here. The vectors can be much more complicated than this when representing these terms, and that's called embeddings, meaning that the term is now embedded within a context. So when you hear that term embeddings, that's what we're talking about. We're going to take this term, or more specifically a token, and we're going to embed it in a context, and that's our vector. And then that vector is related to other vectors. In other words, within this vector space, you might have other terms that show up near that red dot or near that green dot, showing you relations that they have with each other, right? So this is the first thing to understand. Computers think in numbers. That's all they can think in. They don't think in anything else. And there's some argument that we also think in numbers, but numbers in a more analog fashion with much greater variance and almost impossible to nail down levels of detail. But we also seem to have these neuronal connections that work in a similar fashion. At least that's the theory that's out there. There are a lot of other theories too. So how does this get applied? Well, what we do to get our output is, today, we're not going to just use one point of analysis. We're going to go through layers. So at each layer, we're going to have neurons, and then we add another layer, and we've got neurons, and we add another layer, which has our neurons, and then another layer. Now, this is extremely simple. None of the LLMs today are using 4 layers, okay? But we're going to take input to this, and it's going to go through the different neurons for different things to happen. So it's not that every one of these neurons is doing the exact same thing. If that was the case, we would need only one, wouldn't we? We would be using what used to be called a perceptron, okay? But what we're going to do is instead analyze these and feed them into the next layer's neurons, and feed those into the next layers and those into the next layers until we eventually get our output. Now, this was neural networks pre-2017, and even most neural networks for the next couple of years after 2017. But 2017 introduced a concept with this seminal paper called Attention is All You Need, where we said, hey, what about if we add these attention modules into each layer? You could call it an attention layer, you could call it an attention module, but basically we're going to take this concept of an attention component that's going to look at the context at each of these layers and levels of decision, reflecting back on what it knows about that context to better determine the decisions it's going to make. And so we'll have these plugged in at every layer. And that's called a multi-head self-attention model, MHSA, if you care. And we've been evolving this since that time in 2017. People have changed some ideas, come up with new ideas about how to use it and to develop better and better things. We've also added to it some very specific instructions for self-evaluation of the process, leading to these modern thinking models that we call them, that we have today. where they're really just generating output and then thinking about the output that they just generated. And then they go back through it again, and then they go back through it again. And maybe they put some more input into it based on what they found on a website or in some RAG-based information that you provided. That's retrieval augmented generation, or RAG. So the point is that it's going to pull through these various layers to gather this information. Now, the important facts to remember: know the privacy policy of this LLM that you're going to use. For most, deleting your chat also deletes any files or content within 30 days. For most, they do not train on your chats, though a human could look at them and find optimizations for the system. Always avoid PII of your customers. And many API interfaces have a different privacy policy from the chat interface. That's very important to know. So they may have one policy when you're, like, say with Google Gemini, you're using the gemini.google.com, the chat interface directly, right? As opposed to the Google API. And then there are different ways that the API is implemented. So you've got the Google AI Studio, which is a way you can get free access to the Gemini API at what they call the free tier. It's constrained. I'll talk about that more in a second, but it's there. And then you also have the Gemini for Google Cloud. That's now in the Google Cloud platform. You can train your own models. And if you haven't been keeping up with things, when they upgraded to Gemini 2.5, they took away the free model tuning that was in the Google AI Studio at Gemini 1.5 and earlier. So you can't do free model training in there anymore. To do free model training, you have to use Vertex AI, which is in Google Cloud, to do the free model training. And then you've got to use Gemini for Google Cloud. And there's a limit as to how much free you can do, not just constrained by throttling per day, but other things as well. And so there were some changes there. So look around at these different solutions. I'm going to use the Gemini free AI for an example here in just a couple minutes. But don't just assume that's the only thing available to you. So look at what Claude offers, look at what others offer. And it's kind of hard for us to get too frustrated about their throttling, since after all, none of these big AI LLM players are actually making a profit off of anything they're doing. Instead, they're all losing billions of dollars a year. So it's kind of hard to judge them for starting to charge for things in relation to what it actually costs them to provide those things. Give it away at a huge loss to grow the pool, and then charge the real price you need later on, right? That's a good AI or a good IT model, right? We've been using it forever. Know the different models will respond wildly differently. And also keep in mind this layered architecture we just looked at, but remember, there can be dozens or hundreds of layers. It's not just 4 like I showed. And so you can do a prompt in, say, ChatGPT and open a new tab, do the exact same prompt, and get different results. So it's not just about different models, it's even the same model. And each platform offers unique features, so they might have capabilities the others don't. And you are throttled on many free platforms or have missing features. Now, the big thing I want you to keep in mind is to understand how to do prompting. I'm not going to spend a lot of time on this because our community is a little more technical than most. So I'm going to go over it very, very quickly, but you want to give context, and you want to make sure you provide your instruction and an output indicator. So what I mean by context, this is your prompt, your overall prompt, right? And it can include providing data in a file. It can include providing an image. It can include just the text that you input for the prompt. But the point is, think about the context you're providing. There are a lot of things that we've learned over the years that help, like saying, you are what? You are a CWNE. How would you answer this question? You upload an objectives document. Maybe you're studying for CWNP exam. You upload an objectives document and you say, I'm studying XYZ in the context of this certification. What level of detail do I need to learn? Now, you can't trust the LLM is going to be right, but at least it can give you a starting point, right? You can provide a URL and so on. Then the instruction is clearly stating what you want the LLM to do, providing specific and explicit details. And then the output indicator. How do you want the response formatted? Tell it. Do you want tables? Do you want quick bullets? Do you want it in a format like XML or JSON or what have you? So tell it what you want. And that's enough said for now. We'll leave that because I think most of us know more about this, but this is a good thinking model for prompting: context, instruction, and output indicator. LLMs in use. So what do? Do everything you can to easily to your data first. In other words, filter it down to only the needed information for the LLM, clean and prepare it, use an algorithm to hide real IP addresses and node names. Now, this is a trick you can use because a lot of people are concerned about revealing their IP addresses and their node names. What you can do is you can just write yourself a little Python script. And by the way, if you don't know how to do that, go to an LLM and say, write me a Python script, and then does what you want. And basically write a Python script that will change all the IP addresses, but in a way that you can run another script that converts the response from the LLM back to your internal addresses. So you're hiding it. Same thing with your node names, etc. So modify your data with pseudo information, submit the pseudo information, get the results, and then clean the data back up. It's just a tip. I'm not telling you it'll prevent every kind of data leak. You must think about that yourself. Use an algorithm to provide extra insights on the data when required. In other words, before you ever submit it to the LLM, you got some kind of a script that you run, which again could be generated for you by an LLM in many cases, that will take that data and maybe add new information to it from other sources in your environment and so on. Use an algorithm to ensure consistent and proper structure, that if the data maybe has some oddities in the way your systems generate it, if you can clean that up a little bit before, it will help the LLM better understand it. For privacy, consider open source LLM models. So you can use them alone. And by open source LLM, I'm talking about literally you're running the entire LLM locally. Nothing's ever going out to the internet. It's on your local network. There are all kinds of ways to do this and beyond the scope and time we have to get into all the details today, but you can. And it can be used in combination with online models. So you can have your local model for most things, but then maybe it comes up with 5 problems it has detected on your network. And you don't want any details about your network revealed to the online LLM, but you've already detected the 5 problems. Now you can submit those 5 generic problems to an LLM and ask for common recommendations for troubleshooting procedures, et cetera, and so forth. And you can use it with non-LLM AI and other API-based solutions, integrating them together. Okay, so this would be a strategy for using LLMs in your environment. Now let's take a look at some of this. So first of all, let's take a look here at our learning tool in the CNA e-course. Goes over what is a large language model. Simply tells you they're good for answering questions, writing content, summarizing, translating, generating computer code, etc. History, where did it come from? This is something I really like to share with people. I'm not going to go into it a lot here, but you hear a lot about this thing called the AI winter or multiple AI winters. And what those are is time periods when there were lower levels of investment in AI. I mean, we're going to have a ton of AI winters in the future, aren't we? Because never in history have we spent a ridiculously large amount of money on AI like we have in the last 6 years or so. So I don't think we'll see those levels again once we start to slow it down in the coming 10 or 20 years. So we'll say we're in another AI winter. But AI winter does not mean we're not using AI. AI winter simply means that there's not as much investment in AI. AI is being used. AI is being advanced. It has consistently been doing so, certainly since the 1964 Dartmouth conference, but even before that to some extent. It has been moving forward slowly but surely. And so here I kind of break down for you the different eras and the things that were coming along. Then there's an explanation of how they work with a simple interactive animation to help you through that process that we just talked about and understanding its concept, some tips on prompting, and then some network admin uses like monitoring and analysis and configuration and automation. So these are effective ways that you could utilize it. Okay, so that is a little bit more information on it. let's take a look then at how we might use AI to accomplish some things. So first of all, let's just take a look at a simple example. What I'm going to do is I'm going to drag down a file here and put it into my AI. Now, if you read that, you can see it says WPA-4-way. So you probably already know what's in here, but I'm simply going to say, what communication is represented in the attached pcap file? What is the process and how does it work? What details are revealed about this specific implementation of the process? And what do those details mean? Answer like I have a CWNA level of knowledge already. And we click on go for it. So this can take anywhere from 20 seconds to 20 minutes. So what do I mean? Well, if you have a capture file that is massive and has 150,000 different packets in it, then processing it's obviously going to take a lot longer. And by the way, may not even be able to do it depending on exactly what is in that capture file. The other thing is that not every LLM can read a pcap. So for example, if I come down here to Perplexity and I drag that same pcap down, let's go ahead and do that. And it says file type not supported. Uh-oh, I guess it's not possible. Well, what I can do is I can open up the pcap in Wireshark, and then I can say file, export packet dissections as CSV, and then just save that out as a CSV file, which I've already done. And then I can drag the CSV file down. We'll come up here to Gemini. I will copy my prompt, go to Perplexity, I'll paste it in, and I'll say, in the attached pcap file exported as a CSV in Wireshark, and just run the exact same thing. So now that I've made it a CSV instead of a pcap, Perplexity's like, oh yeah, I'm good with that. I can process that. So let's see what Gemini found out when looking directly in the pcap without me needing to convert it first. And you will see here, it says, yeah, based on the provided file name, it looks like it's probably WPA2. And then it says the purpose of the four-way handshake gives me the messages, details revealed. It's actually giving me an a nonce value that it's all confused about. But at the very least, it's telling me what these nonces are for. Gives me an algorithm for the PTK. Then we've got our message integrity code, key installation in GTK, and what it's calling snippet 3 represents message 3 of the handshake and so forth. Now, there are a few things to keep in mind here. First of all, LLMs are great for giving you insight into what kind of stuff it's seeing in there and things like that. Are they going to capture everything? Yeah, maybe, maybe not. So LLMs have some bad habits that seem to still be in a lot of them, even today. Yes, even with ChatGPT-5, which, by the way, has gotten some really bad press in the last 5 or 6 days. But even with the newer models that come along, they seem to still have this front-loaded proneness, I call it, which means that if you give them some large chunk of data, they tend to look in the early sections of the data. And if they feel like they found what they need, they just give you an answer and move on, and they don't go through the entire data set. Even if you give them explicit directions, like make sure you read every word of this data set and don't stop looking just because you think you found an answer, but continue on and see if your answer can be improved. And I mean, you can do all that kind of stuff, and sometimes they still don't look beyond the earlier sections. They're getting a little bit better at that. Notebook LM was really bad about that when it first came out, giving you only answers from early on in any documents you put in the notebook, but it's gotten better at it. Again, still not perfect. So you've got to really know your data and know what probably ought to be in there and whether you're seeing the results that you would expect to see or not. Now, when we go over to Perplexity, we can see here, okay, it's giving me the 4 rows are the EPAL keyframes comprised of the WPA2 4-way handshake, giving me what message 1 is, message 2, and so forth, tells me how it works. Then it looks at the specific capture, and this one's giving me a lot more information, which makes me step back and say, how much of Gemini's answer was based on just the name of my file and it guessing things, and in other words, hallucinating, versus being able to look inside? Because Perplexity has given me a lot more insights. I mean, it has detected that it looks like based on the MAC address, it's a Cisco AP. It's got all this extra information of actual data content. Gemini should have been able to do that too. Well, this is the point. You have to work with these tools to really see what they can do. My experience so far has been that the best way to do pcap analysis with LLMs is to export as CSVs and then use the CSV as your data source. You can tell that the CSV was exported by Wireshark, and that does seem to me to help the results a bit. But again, I have seen a lot of things that sure appear to me to be total hallucinations when it comes to directly trying to analyze a PCAP. And so personally, I appreciate the fact that Perplexity just tells me right out, I don't really know how to do that. And by the way, one of the reasons I like Perplexity is because of this right here. So one, I think it's $20 a month subscription to get the pro level. And you've got access to Claude, Gemini, GPT, Grok, and so forth built right into it. And so that gives you a lot of extra capability as opposed to, if you subscribe to ChatGPT, all you've got is ChatGPT. Gemini, all you've got is Gemini, and so forth. So that's a nice feature. And in your settings, you can set what you want to use as your default LLM. And then the other thing is it does have, of course, a deep research mode. And my absolute favorite feature is this globe right here, where you can go in and tell it, look at academic papers. And so instead of just searching the web, which is going to get, everything you could imagine, it's going to look only at academic papers, which is really good when you're doing research in that area. So I'm a big fan of Perplexity as my daily driver for AI, although I find myself using others for other purposes that they tend to be very good at as well. Obviously, ChatGPT can also be used for such PCAP type analysis and things like that. But one of the things I want to look at is being able to automate some things. And so when we look at Gemini, for example, and I'm just using this as an example, pick your favorite one that you love. But they all have APIs so that you can communicate with it. So I'm in Google AI Studio. And the nice thing about this is you can go to API keys. So just log in with your regular public free Gmail account. Create a free Gmail account if you don't have one. And then once you're logged in, go to aistudio.google.com. Go to API keys and click on Create API Key. I already have one, so I don't need to do it. Click on Create API Key. And it's going to look like, it's trying to push me into the Google Cloud and all this stuff. Just go through the process. When you're done, you'll have your API key. And you can use that API key and never set up a billing account, never put any payment information in at all. The only thing is your scripts will simply time out and break and not work when you've consumed all of your allowed free uses. And there are limitations. So let me just show you, for example, and you can look for this kind of information for any of the free APIs. So Gemini's free API has limits, and for the 2.5 Pro model, 5 requests per minute, 100 requests per day, 250,000 tokens per minute. That's pretty good. That's a decent size. And that's like a whole book, right? And then there's an unofficial cap of 6 million input tokens per day, quote, has been observed. And this is even, by the way, Google using their AI to tell me that. They're not even looking at their own knowledge to say, is that true? Or has it just been observed? So you got to love what these large language models do. Flash, 10 requests per minute, 250 requests per day, 250,000 TPM, that's tokens per minute. And then Gemini Flash Lite seems to have different ones. Now, the other thing is to know that there are limits on your total requests per day. So I went down a little bit further. I asked some questions to find out more. And, oh, wait, maybe I didn't do that. Let's see. Is it up here? The total tokens consumed in a day may cause a hit to a daily limit, even if you're under the requests per day limit. So you can get hit because you use a lot of tokens. Maybe you're less than the number of day you're allowed. So you can have 1,000, you can have 250, you can have 100. Well, yeah, you can have 100 if it's a tiny request and a tiny response. But if you're submitting, 12,000 tokens and receiving a 10,000 response, you might be done with only 10 or 11 requests, or even with only 3 or 4. And according to the best I can find, is Google resets Mountain Standard Time midnight every day, and not like a 24-hour window from the first time you used it or something like that. I'm not even sure on that. It's kind of hidden to us, but that seems to be the best I can find. So Google AI Studio, you can get your API key, and then you can see under usage and billing how many times you've used it. I've used it a couple times in the last couple of days, developing a script that I can show you for this. And so, we have that there. All right. So now we'll take a look here. So this is a really pretty simple script. I mean, it looks like it's doing a lot, but it's pretty simple, and I'll explain it to you. So it's a Python script. We're importing the OS library, JSON, collections, requests, and time. We're setting up a variable for what our log file should be. Since there's no path, it'll be assumed to be in the same directory or folder as the script. We've got a model list, which gives us Gemini 2.5 Flash and Gemini 2.5 Pro to choose from. I'm selecting Flash, and all these things right here doing is given an easy way I can modify the script to go from the Flash model to the Pro model or vice versa, and have it automatically, dynamically build my API URL. So it changes this section in the middle so that my URL is appropriate. By the way, a little trick here, you'll often see people in videos saying, oh, use your API key, and then you'll see them have their API key kind of hidden in their script. In other words, they blur it out or something. There's a trick you can use if you're going to be sharing your script so others can see it. This os.getEnv allows you to get an environment variable, and you can set that environment variable to be your API. So you're not even going to have to enter it. And so we're saying the API key is either equal to this, or if that returns nothing, then set it to enter valid API key here. Okay. So it's just a way for you to use an API key without having to either delete it after your demonstration or something of that sort. And so then we have our URL. We're going to do our API request with a backoff timer. So in this case, we're doing an exponential backoff with each iteration, so it'll delay more and more. And that helps when the server is throttling you or something like that, and you need to retry once the throttle is opened up again and you can continue. And then we've got a process where we analyze the log file itself. So we're going to read, and we're going to read in 500 entries from the log file in this case. So there might be thousands. We're going to read in 500. Here's the actual fake log, completely fake. But as you can see, there are in this completely fake log 1,200 entries. Okay. And it has things in it like infos and warning, excessive retransmissions, high channel utilization, abnormal roaming, et cetera, and so forth. And then we read in the first 500 lines. And after we read that in, then we construct our prompt. Now, if you wanted to use code like this, you would need to alter this prompt, obviously, for your data. So I'm using a prompt based on that dummy data, which has failed authentication, low signal quality. I'm looking for other things. I'm looking for association timeout, IP conflict, excessive retransmissions. I'm looking for a lot of different things, telling it how I want to answer. And then right here, I'm actually defining the JSON structure that I want it to use in its response. So if you want to add more key value pairs for JSON that you're going to reference in your prompt, you need to add them down here. Because if you just put them in the prompt, the API is going to restrain itself to this construct. Therefore, you're not going to get that extra stuff you're asking for. So you have to make sure that you include this. And then you're going to call the actual API. And you're going to look at the response and do error checking. That's what all of this is doing. Then you're going to actually run things. So this part right here, if dunder name dunder main, that's just a Pythonic way to say if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore, then we're going to run all of this. And what that simply means is I'm running this code directly, because otherwise dunder name would not be equal to dunder main. Okay, it's not the main module. So this code only runs if I've run it directly. Otherwise, I can load this entire Python script as a module or a library for other Python scripts to use, okay? And so what it's going to do then is, in this case, I just have the script create a dummy log file in case you don't have one. So that's all that does. And then analysis results, we set it to false. We say, hey, if the API call is equal to, key is equal to enter valid API key, print a message that says, how about you enter an API key, buddy? And otherwise, we output the results. And then if there are no analysis results, we're also going to say log analysis failed. Okay, simple as that. So that's basically what our script is doing. And by the way, we're going to be posting this to YouTube. If you're watching it on YouTube, you know that it is posted to YouTube. And down in the description, I will add a link for you to get this Python script and sample fake log data. And then you can play around with it to your heart's content. Of course, you'll have to get your own API key for it to work. So there's our script. Let's take a look at it. I'm going to bring in my command prompt. And the first thing I'm going to do is take it back off again before I accidentally reveal something on the screen. Okay, so we're going to go ahead and run this. And it says, how about you enter an API key, buddy? Log analysis failed. Well, that's because I don't have the API key in my temporary system variables. So I'm going to go ahead and in my environment variables, off screen, add my API key. And now that my API key has been added, I'm going to run the code. And it's going to take a second because it's uploading 500 log entries. I didn't abide by my advice. I didn't clean out the stuff that don't matter. I'm making the LLM look through everything, pick out the log entries that are of importance, and then respond. And it's going to give me a response. Well, hopefully, if I don't get an error, it's going to give me a response that says, here are the flagged log entries. And then it's going to give me some recommendations for how to troubleshoot and address those issues. So we wait. We wait very patiently. We wait a little long than is comfortable for Tom, making me wonder if it's going to work in the end. Is this going to be a Bill Gates plug in the scanner demonstration from the 1990s? We'll find out, won't we? I sure hope not. With the time I invested in developing this script, it would be painful for it to not work when I run it. We're going to let that run. While that's running, I'm going to show you one last thing that I want to address with you before we get done with this webinar today. So let me pull this up and out of the way while that's running. I want to show you another thing you can do. So I've run a script that is doing what it's doing. And the reality is that you may actually need to automate several tasks in a sequence. And that's where workflow automation comes into play. And one of the best tools going right now is N8N. It's at n8n.io. But the key thing I want to point out to you is that, yes, you can go into pricing. You can see how you can pay for it and things like that. But if you go into the hosting documentation, there's an option for self-hosting, which means you're going to run your own local instance of what is called the Community Edition. Will it have all the power and features of their cloud-hosted version? No, but it may have everything you need. So you can host it locally. You can even do it using Docker containers and things like that. One of the coolest things that they've done is they've built a starter kit for you. And when you look at that starter kit, it's really cool because it's giving you N8N, Ollama, Quadrant, or Quadrant, some people say, which is a vector store for storing your vector data related to your LLM, and PostgreSQL for your database system. In other words, it's not just giving you N8N, it's giving you a local implemented open source LLM. And once you implement Ollama itself, within Ollama, you can download different LLM models that you might want to try and see if they're going to work for what you need to do, that kind of thing, okay? So that's a really cool option. And you basically just go to their GitHub repository right here, and it steps you through the whole process to clone this down to your local environment. And so you can really get a cool thing up and running in your lab to start playing with and testing this very quickly. That's N8N. So N, the digit 8, N. All right, Tom is much relieved because while I was explaining that to you, it did finally respond. So it has looked through those last 500 entries and it found these warnings: interference, deauth storms, abnormal roam latency, low signal quality, etc. And then it gave me the following recommendation. It says, to address the detected issues, a multifaceted approach is recommended. For interference, do X. For deauthentication storms, do Y. So it gave me that, right? Well, the point is, if you decide you're going to play around with this script, again, I'll have a link to it once this is uploaded to CWMP TV on YouTube, where you can download both this script and the sample log data, and you can modify the structure of the log data. You can use a real log from your environment that you clean up and get private information out of, or anything like that you want to do. So it will be available to you. You can go in and change that. So if you go into the actual source code of the Python script, what you're changing, again, is right here. So you can tell it in the response. You can say, I'm a Wi-Fi god. I know everything about Wi-Fi, so don't talk to me like I don't know what I'm doing. Tell me advanced recommendations, right? You can do whatever you want. You could take it a step further and you can provide a 1,000 or 2,000 or 10,000 words of text explaining recommended solutions to common problems. And that is something that you can do to just change this prompt. Everything else in the code can stay the same. You just change the prompt. If you don't know much about Python, watch out for the fact that you got to make sure when you're doing multi-lines like this, that you close out each line with quotation marks. Don't use quotation marks inside the line. Use single quotes instead. Be careful that you don't mess up the string that we're building here. And if you want to play around with changing the actual JSON response, you want to add something new, then define up here in your prompt what you're adding new, like where we talk about the recommendations key here, talk about your key, and then all you do is come down here and say, comma, carriage return, quote, whatever your new key is, quote, colon, whatever your value is going to be based on the type of data. So just make your adjustments. And my recommendation, obviously keep a working original copy of the script. So if you mess something up, you won't break everything. Now, one final thing to tell you about this script. The other thing you could do is copy it and paste it into Claude or Gemini or whatever, ChatGPT, and say, tell it, modify this script so that X. Ask it to make the changes. So if you don't know Python that well yourself, ask it to make the changes and then try the results. Just be careful. Make sure you're in a safe space. I don't mean emotionally. I mean networkally. So make sure you're not actually touching any real equipment or anything like that. Do it in a lab. Do it in a protected sandbox, and you should be okay. All right. That gives you an idea of what you can do with LLMs.